Welcome to Chipus of Math Physics. Again, today we'll be dealing with calculus, and here is a question that is a bit tricky and confusing to so many students. I will take you through it, and I hope you will enjoy it. A lot of people have called me. I want to thank all of you who continues to follow me on Instagram, on Facebook, on Twitter, and on the YouTube. Do well to subscribe if you are joining us. This is a calculus class, and we have a question that asks us to show that a certain function is continuous everywhere. If you are joining us, watch the part one, the introduction, so that you get to understand what we mean by evaluating some limit and showing that a certain limit is continuous everywhere. Like, seriously, let us find out if it is continuous everywhere. Here is our question. We are to find the value of the constant, to find the value of the constant P and Q, so that the function, and the function is here, it is f of x is equals to px minus 9, as x is less than equal to 2, and we have x cubed minus 9. 2 is less than x less than equal to 3. We have 3x plus q. X is greater than 3. So we are to find the value of p and q, where we have p and we have q here. So why are we doing that? Is to show that this function is continuous everywhere. It sounds funny, but that is what it is. Some people used to say it is what it is. It is just what it is. It is funny, but that is exactly what it is. We need to show that function is continuous everywhere, both on the negative x-axis, on the positive x-axis, on the negative y-axis, on the positive y-axis. It is just continuous everywhere, and this is a kind of question that is a bit tricky to so many students, but let us see how to do it. First of all, let us clean up this. I have written the question up there too, so that we are able to follow the calculations. Good. First of all, you need to know that the function f of x is continuous at x equals to 2, because we are told that px minus 9 as x is less than equal to 2. So it is continuous. We say that f of x is continuous at x equal to 2. Because when you say that a function is continuous at x less than equal to 2, it means that they are equal to 2. They are less than equal to 2. So therefore, x, our function x, is equal to 2. That is the step one. And if it is equal to 2, we know now that we need to replace f of 2 from the negative side. F of 2 from the negative side is also 2. So it means that it is equal to what? 2. F of 2 is equal to 2, or you can write f of 2 is equal to f of 2. And if it is equal to f of 2, it simply means it is equal to f of 2 from the positive. It is a bit tricky, but that's exactly what you need to do. So therefore, it implies that f of 2 from the negative, which is equal to 2, so now you can remove this negative sign, is equal to f of 2, which is from the positive. It is equal to f of 2 from the positive. And if it is equal to f of 2 from the positive, remember here we have px minus 9. So it simply means that you start by solving. When we replace this variable, we will have p x of 2. We have 2 minus 9 that we have there. And this is equal to, what we have here is x cubed. So it is 2 because it is f of 2. So x is 2 cubed. Then minus 9 we have here. That is the dot step. Now we can open up what we have there. This simply means, to get this simply means that 2p here minus 9 is equals to 2 raised to power 3. 2 cubed will give you 8. And this 8 minus 9. This simply means that we have 2p minus 9. We have 2p is equals to 8 minus 9 is what? Minus 1 plus 9. Because we take this 9 to the other side. So you will have 2p is equals to minus 1 plus 9 will give you 8. Therefore, p is equals to 8 divided by 2. So we implies that our p is equals to 4. And that is the value of p. But we have to find the value of both p and q. So now we need to find the value for q. The value of q, to show that this function is continuous everywhere. All we are trying to prove is that the function is continuous everywhere, and I hope you will enjoy it. So now, remember, we said that f of x is continuous at x equals to 2 because x was less than equal to 2. And we know that 2 is less than x and it is also less than equal to 3. So it means that the function f of x is also continuous at x equals to 3. So we can say that f of x is continuous at x equals to 3, which is this. And if it is continuous at x equals to 3, it therefore means that our f of 3 from the negative side is equals to f of 3. And if it is equals to f of 3, it simply means that it is also equals to f of 3 from the positive. I hope you are getting the logic. And if it is equal to 3 from the positive side, what we have done is that f of 3 from the positive, which is just f of 3, is equals to f of 3 from the positive. Are we there? At any point in time you try to pause the video, do it yourself so that you get the concept. You know, mathematics is all about practice. Practice makes perfect, or what we say that practice makes permanent. All we are trying to show is that this function is continuous everywhere. Everywhere. You can imagine that. In your village, it is continuous. In town, it is continuous. Both in rural areas, urban areas, wherever you are now, the function is continuous. Everywhere. So let us prove that. We have said that f of 3 is equals to f of 3. It means they are giving us the same answer, which means it is continuous. But we know that x is, we have x cubed. So what is in your mind? It implies that 3 will be cubed. And if the 3 is cubed, it is minus 9 because we have 9 there. Which means that we have 3x, it means it is 3 multiplied by 3 plus q. 3 multiplied by 3 plus q, because here you have q. And we are looking for q, that is our target. 3 cubed will give you what? Put in your calculator. What do you get? I guess you will have 27, because 3 raised to 3. 3 cubed is 27. 27 minus 9. So 27 minus 9 is equals to 3 by 3 will give you 9 plus q. This simply means that 27 minus 9, it implies that this will give you 18. 27 minus 9 is 18. So it is 18 minus 9, which is equals to 18 minus 9 is equals to what? Q. You can pause the video, try to do it yourself, so that if you get lost at any point, you will find. Put in your calculator, what is 27 minus 9? 27. 27 minus 9 is 18. And we know that 3 cubed is 27. So 27 minus 9 is 18. 18 is equals to q. So now you have 18 minus 9, which will give you 9. So therefore, q is equals to 9. And we are good to go in that, because our value for p was 4 and our value for q is 9. So therefore, we can conclude that the value for p is equals to 4 and the value for q is equals to 9, meaning that this function is continuous everywhere. I hope you enjoyed the video. That is just the only way to go about it. See you in my next video, as we take you more in advance to show that a function is continuous everywhere.